Super. I'll just, okay, great. So welcome everybody. I'm Margaret and Inez is on the other line, kindly sharing her screen. And we are talking about graduate studies today. So next slide, please. Thanks. So grad school is a master's or a PhD program following the completion of an undergraduate. You can do two kinds. A Master's of Applied Science, which is more of a research-based master's, or a Master's of Engineering, which has extended coursework from your undergrad. Coursework is usually about 4 courses per degree, although some PhD students take up to 6. As I mentioned, you usually complete a research project and write your thesis on that, and then defend that thesis at the end of your degree. Your research project is based on your laboratory work, and that can include imaging, data analysis, all kinds of cool lab things. You get to work on funding and scholarship applications, which are always really interesting. Teaching assistant work, and of course, you can publish and speak at conferences on your research project and your thesis. Basically, it's the best of student and adult life. Next slide, please. Thank you. So why would you even pursue studies? Well, a lot of students pursue graduate studies to have a career in research and development or in academia, although those aren't the only two places that you can work. If you are interested in studying a field at a more depth or contributing to new discoveries and innovations, then grad studies might be for you. In industry, there are often positions that require or prefer engineers with a master's degree. So graduate studies is a really worthwhile thing to get you sort of out of entry level and up into kind of more management type work. Next slide, please. So we thought we would give you a couple of examples of what graduate work might look like. At Dal, there are 2 particular disciplines that you can only do in graduate studies, and we're going to walk through those real quick. Materials engineering, which is very Inez and I are both biased because this is what we work in. Materials is a really exciting branch of engineering. It's got really broad application, and we're going to just a couple of them that are the most interesting to me anyway. Additive manufacturing is an up-and-coming kind of type of making things, and they're shown in the bottom right and top left images there. Basically, it's as opposed to subtractive manufacturing, which is traditional sort of types of manufacturing. Basically, it's where you take a block of something and then cut it down the shape that you want. In additive manufacturing, you start with really, really tiny particles and you build it up into the shape that you want. So you can get more complex or very interesting shapes from additive manufacturing. And it's usually done, with a combination of pressure, heat, and sometimes lasers, which are very fun to work with. Other applications of materials engineering are, of course, the electric batteries that you keep hearing about from Tesla and other sources. So that's the top middle image. There's always a materials engineer involved in that at some point. Similarly, top right image, you got a gentleman there who's got a prosthetic limb. There's definitely been a materials engineering involvement there at some point along the development of that device to give work with biomedical engineers and doctors to see what the best sort of materials properties and combination of properties that might support that requirement the most. So we've also got materials engineers can also work in the energy sector, particularly in turbines and solar cells. So that's the bottom middle section or image there. Turbine blades are a particularly interesting application for materials engineers. And of course, for any Star Trek and Star Wars fans out there, on the bottom left image, materials engineers are always involved in aerospace. the ceramic tiles on that space shuttle there, they're heat resistant and they're also quite strong. So a materials engineer has definitely been involved at that at some point. Next slide, please. Getting all kinds of notifications here. So the next sort of specialization spotlight is biomedical engineering. Again, it's something that you can only do in graduate studies at Dal. It's very exciting, very cool. There's a very strong research focus on tissue engineering in the biomedical department. And that sort of works on things like skin grafts, on prosthetic or artificial organs and artificial, dental work, that kind of thing. It's very cool. And there's a very wide range of stuff that you can do with it. There's also a strong research component on medical imaging and medical devices, and that's the top two far right or two most right images on the top. There's also quite an interest in prosthetic limbs and hands and implants. That's indicated by the bottom left image here at Dal, so that's very cool work as well. And as I was saying, that's sort of where you might get a crossover between a materials engineering application and a biomedical. And there's also work being done on drug delivery. So if you can move to the next slide, please. Oh, there we go. So even though those two, materials and biomedical, those are both disciplines that you can only work on in graduate studies. That's not to say that there isn't work that can't be done in other disciplines. Here at Dal, there's a very strong industrial engineering research into streamlining of factory work in factories, rather. So there's the top right image there. There's also a lot of work being done in the mechanical and electrical departments into robotics and microelectronics. The middle right, in the middle top image there. There's a lot of work at Dal, as I was saying, in robotics and drones, and there are particular applications in underwater viewing and underwater cameras. So that's always very interesting stuff. You can go past labs and watch drones fly about. It's great fun. And of course, also at the civil engineering, they have a very strong structural research group. And similarly, the environmental research has an interesting focus on wastewater treatment and sewage. As I mentioned earlier that the mechanical work is in drones, there is some, but there's also a strong modeling component, which is sort of the middle image there, and you can see the streamlines modeled around the hull of a vessel. Last but not least, the chemical department. They have a strong process safety research, and that's the bottom right image. And they look at things like dust and how we can improve the safety of workers in a variety of industries. Next slide, please. So when we were putting together this presentation, we thought that one of the best ways to convey grad school to you would be through our own experiences. So about me, I did my bachelor in materials engineering at Dalhousie. I graduated about a year and a half ago in 2019. My co-op placements were as a research assistant at Dal, which is how I first in doing a master's. And from there, I started a master's of applied science in materials engineering. My research focus, as you may have got from my little talk about materials engineering earlier, is additive manufacturing and powder metallurgy. And those are both working to improve the existing manufacturing techniques that we have for many of these things. My current research is in aluminum powder metallurgy. I'm not allowed to talk about aluminum powder metallurgy at home because apparently I talk about it too. Next slide, please. Thank you. To give you a little sort of snapshot of my project, my thesis title is an investigation into the hot extrudability of aluminum powder metallurgy alloy 6013. which sounds very fancy, but really is just looking at how I can better improve the manufacturing of that particular alloy, see if I can use the processing differently. Powder metallurgy, type of additive manufacturing. It's where metal powders are blended and compressed into the shape that you want, the end shape. And then sintered, which is just a fancy tech term meaning baked or cooked to form a strong solid shape. And that's a little sort of flow chart on the right there to show you the kind of basic steps in the end that you get. It's really exciting because there's no extra machining required, which is obviously very economical for a lot of industries. And it also allows you to use new materials that you wouldn't necessarily be able to process by traditional techniques. You can definitely use them in powder metallurgy rather, and in additive manufacturing to give you the shape, so you get access to all those kind of interesting properties. With all that ability, it's got an application in a wide range of things, from automotive, which is where I currently work, to aerospace and biomedical applications as well. So it's really interesting and very exciting. Ines, I think over to you.
Okay, perfect. Thank you. Can everybody hear me? Is my audio good?
I can hear you. Yep.
Oh, okay, perfect. So my name is
Yep.
Ines, and I did my bachelor in electrical engineering in Moncton. And then throughout my undergrad, I did co-op placements both in academia, just like Margaret did as a research assistant. That's very useful to know if research is for you. But I also did some of my co-ops in the manufacturing industry because I really wanted to make sure that grad school was for me. And it was, and I decided to do my master's in physics at Dalhousie. So I did my MSc, and I'm now doing my PhD in materials engineering. So I just want everybody to know that what you choose as your specialization in your undergrad doesn't have to limit you in what kind of research projects you want to work with. So I did electrical, and I'm now working with materials, also in the automotive industry, just like Margaret did. And when you start a new grad project, you're going to have to learn everything about it anyways. So you're not at a disadvantage just because you're doing a type of engineering that is maybe slightly different than what you did your specialized undergrad in. So don't be afraid of that. And just really focus on choosing a project that you're passionate about. So for me, my research interests were always sustainable development. I've always been, about environmental causes and about green energy and electric vehicles and recycling. So the current research that I'm doing right now is lithium-ion battery research for electric vehicles. So, just to give you an idea more specifically into the kind of stuff that we actually do as battery researchers. So, a battery, as you know, it's a pretty simple device, but it stores chemical. It chemically stores energy. It contains very high energy dense metals, and it's also an electrical component. So it's a very complex piece of technology. It's a very multidisciplinary project. So on our team we have chemical engineers, process engineers, material engineers, mechanical engineers, electrical engineers, all the engineers that we can get really, because there's so much to do. Lithium ion cells have only been known since the 70s, and they only began to be commercialized in the 90s by Sony. I know that they feel like they've always been around, like in our smartphones and our laptop, but they're actually quite new. And there's so much work to be done to make them better, to make them last better, to understand the failure mechanism inside of them. And so those are the kind of puzzles that we work with. And that's what grad students do, right? We have this big puzzle, and we need to use all the science and the engineering we can to fix this problem, satisfy our clients. So, more specifically, in our lab, we work on very practical things, right? Our industrial partner, they tell us what they do, what they want. They want batteries that have higher capacity and energy. They want batteries that last longer and that are faster to charge, right? So we can compete with the combustion engine. And so that's what we physically do. We go into the lab, we invent and design new materials, we physically make them ourselves. We physically make like I go in and I make batteries with my own hands, and then I test them, and then we analyze them and image them, and that's basically what research is. And it's very cool. If you like practical work, it's very very hands-on. You can do theoretical research or computational research as well, but there's really stuff for all tastes. We're kind of almost at time, so I just want to leave a couple of minutes for you guys to ask me or Margaret any questions.